Hi guys, my name is Jeremy Gibon Cantin and I will assist you with the functions. We're gonna do piecewise function, unit step function, and delta function. A piecewise function will help you when you are dealing with your Fourier series, when they ask you to do to graph three cycle, for example. And the unit step function will help you when you are dealing with your Laplace transform, specifically when you are dealing with unit step function, when they ask you to do the solving it using the first principle. So this will help you. And also, let's start. Before doing the piecewise function, you have to know the general, how can I graph. So here are the typical functions. They're usually gonna ask you a constant, okay, and then for you to graph this function, it's simple. All right, no matter the value of x, your function will always be at 3, for example. How do I know that? For example, if they ask you find f of 2, it's still going to give you 3. Find f of 100, it's still going to give you 3. All right, so it's going to be a straight line, but a horizontal straight line. All right, for example, if they ask you to graph f of -1, okay, if they ask you f of x equal to -1 and they ask you to graph it, it will be what? It's going to be like this. This is -1 here, so it's going to be like this. All right, the horizontal line and so on. Okay, so now the second type you'll find is linear function, and then it's a linear function is equal to mx plus c, and then this graph depend on what? It depends on the value of m. If m is positive, if something happen, m is positive. If m is positive, your graph will look like this. All right, and then if m is negative, your graph will look like this. Obviously, they are straight line, but it's how do you call it? A little bit inclined. All right, it's oblique. In French, they call it oblique, la ligne oblique. All right, this is how the shape will look like, depending on the value of m. All right. So, for example, if you ask me to graph this f of x equal to 2x plus 1, there's a little trick you have to do. Please, if you can draw for me the table, you write x here and then you write f of x here. All right. Remember, in this function, I do not have any restrictions, so I draw it how I want. All right. So I have this, something like this. For me to graph this, let me choose random numbers. I'll go for 0, for example. If x equal to 0, f of 0 will be what? F of 0 will be 1, correct? Yes. If x is this your 0, if x equal to 0, then your y, which is f of x, will be equal to what? If f equal to 0, then your f of x will be 1. This is your 1. It's sitting right there. Okay. Now let's take another point, because you know that you cannot draw a line with only 1 point. You need 2 points to be accurate. So let me choose 1, for example. If f of x equal to 1, what will be? If x equal to 1, what will be f of x? I put 1 here. It's going to give me 2 multiplied by 1 plus 1. It's going to be 2 plus 1, which is 3. So I'm going to have 3 here. Then I can draw it. Okay, they say if f of x equal to 1, then my f of x will be equal to 3. 3 will be somewhere there. So I'm going to join them. It's going to be right here. And then my graph will look exactly like that. All right? Okay? Then it goes, because I don't have restriction, I draw it how I want. All right, and then you see, because x was positive, I get this type of line. But now let me twist it a little bit. If I had, for example, if I had something like this, if I have minus 2x plus 1, that's my f of x, what will be my graph? Please always try that table, it's very important. Let's take 0. If f of x, if x equal to 0, y will be definitely equal to 1, all right? And then if I take, for example, minus 1, or if I take, let's take minus 1, all right? If x equal to minus 1, therefore I will have minus 1 times minus 2 times minus 1, it's give me 2. 2 plus 1, it's give me 3. All right, so let me graph this. When I have 0 here, if x equal to 0, y equal to 1. And if x equal to minus 1, y equal to 3. This is 2 and 3 will be here. 3 is right here. 3, and then it's gonna be like this. Okay, and then I'm gonna graph it. I'm gonna join them. We say when x equal to 0, y is 1. And when x equal to minus 1, y equal to 3. So I'm gonna join these 2 points. There you go. And then you can definitely see that this line is like this. All right, good. And a quadratic equation, something happen when you have a is positive, when a is negative. When a is positive, your graph will look like this, a smiley face. When a is negative, you're gonna have a front face. All right, so we will definitely see this. For example, I'm just gonna get a small example. If x is equal to x squared, for example, usually, please, I want you to be to use the table because it's very helpful. So I'm gonna have something like this. I have x, and then I have x squared, f of x here. Okay, if x equal to 0, this thing is 0. If x equal to 1, this one equal to 1. If x equal to 2, or let me say minus 1, it's gonna give me 1, and so on. All right, so you're gonna have something like this. Okay, now let's now start. Let's solve this question. Now here you have what we call restriction. So you cannot just draw them like as you want. You have to focus on the restriction. For me to draw this, I'm gonna have something like this. This is my Cartesian plane. This is my x, this is my y. All right, let me tackle the first one. They say f of x equal to x when x is less than 0. So usually for you to be in the domain, or for you to be in that interval, you must check this. You take that value, you put it in your equation. It's gonna be, you take that 0, you put it here. If x is 0, it's gonna give you what? If x is 0, no matter, even if it's written like this, but you take that exactly that, because I want you to be in a domain. I want you to be in the restriction given to you, in the limit given to you. You take exactly that number. I'm insisting. You take that 0, you put it here. It's gonna give you, if x equal to 0, then y will be equal to 0. Okay, it's here. But if we want to be very strict, then is it gonna be, there are two type of dot. It's solid dot or open circle. All right, if it doesn't include it, you put open circle. If it does include it, it means equal to, you put the dot. So here you see that it doesn't include it, but I'm not strict here, so let's leave it like that. So if I want to be strict, it's gonna be like this because it doesn't include it. Open circle. Now you know, for you to graph a line, a linear function, you need what? You need 2 points. Where am I going to get the other point? You go back to your limit. You check how the limit is defined. They say x should be less than 0. So you take any other number which is less than 0. What is less than 0? You can take -1, for example. So if x is -1, your y will be what? Your y also will be -1. You are here. Okay? So it's going to be, you link them, this point. And then your graph will look like what? It's going to look like this. Okay? So now let's talk about the second point. What is the second point? X is greater or equal to 0, and then the function give you to 2. So you already know how to solve when you have 2. When x is equal to what? 0, greater or equal, I'm here, I will have something like this. And then I am exactly in my interval. Okay? So now let's tackle the second question. For example, if they give you something like this, f of x equal to minus x if x is less than 1, and then x squared if x is greater or equal to 1. How will I graph this? Simple. You take what is in the interval. You check here. When x equal to 1, what will be your f of x? If x equal to 1, my f of x will be what? It's going to give me -1. -1. Okay? If x equal to 1, that thing will be -1. I'm here. Let me just put this one aside. Okay? And then I have to find, I already know that this is a straight line because my function was a linear function right here. All right? So I have to take the second point. Which point can I get? It's defining that x is less than 1. So I'll take any point which is less than 1. Let's go for 0. What will happen if x is equal to 0? If x is equal to 0, your f of x also will be equal to 0. It's right here. Okay? So my line will be what? And if you remember what we said earlier on the typical function, if my this equal to minus, it goes like this. Exactly, when you see, exactly like that. Okay? And then what happened to your, at point 1, I'll put a open circle. But I'm not going to be strict if you write just a line like that, okay? Okay? But it must show me that it's right there, okay? So, now, let's continue. Let's tackle this one. You will do what? Same thing. You take that 1, you put it here. When x equal to 1, and it does include it, when x equal to 1, your f of x will be equal to 1 also. Okay. If to 1, your f of x will be equal to 1 also. Okay. Now let's take any other number. We can take any other number. Let's take 2, for example. But any other number that respect that is x should be greater or equal to 1. So let's take 2 because 2 is greater than or equal to 1, right? So we take 2, for example. If I put 2 here, it's going to give me 4. If I put 2 here, it's going to give me 4. All right? So how will my graph will look like? And I notice that this is positive. It's going to be like this. And then it continue and so on. All right? This is it. So let's take the last question for this. And then we're going to do what you call unit step. I'm gonna do it in a separate video so that I don't want it to be that very long. F of x equal to, for example, minus x when x is less than 0, and then we have x squared when x is between 0 and 1, and then this one give you 1 when x equal to greater or equal to what? Let me say 1, okay, for example, like this. Okay, let's solve this question. It's very interesting. Please, I want you to see the restrictions and where the function is defined. All right, so I close my eyes, I check this. When x equal to 0, I'm the first here. When x equal to 0, even if the root x is less than 0, you take that value, you put it here, because I want you to be inside the restriction. You take that 0, you put it here. If x equal to 0, your f of x will be 0 also. You are right there. But because it doesn't include it, you can put your rounded, but I'm not strict about that, so let's put that. We are at 0 here. All right, so now let's take any other numbers that we want. Let's say any other number but should be in that restriction. Let's take minus 1, for example, or minus 2. So if x equal to minus 2, for example, what will be your f of x? Your f of x will be equal to positive 2. This is 2. So I'm gonna right here, because you know, for you to draw a line, you need 2 points. So there we go. All right, there we go. So let's talk about the second part. This one. Okay, please, you use what you have here. Okay, so you take first here, that's limit. You take 0, you put it here. When x equal to 0, you put it here. It's going to be 0, so f of x will be 0, right? Yes, 0, 0. Now when you are here, you take this x 1, you put it here. If x equal to 1, yeah, you take that 1, you put it here. Your what? Your x, your x, f of x will be equal to what? It's going to be equal to 1 as well. So yeah, 1, 1. Yeah. Okay. Now the question will be, how will you graph that? Obviously, it's going to give you that curve, because it should be between what? 0 and 1. 0 and 1. So it's going to be right here. That little curve. It's not a straight line. It's going to be a curve because I have a quadratic equation. Remember that, please. Now, what is the last point? The last point is, because it's 1. This is my 1. Then we go like that. Please. Okay? There we go. So this is basically how to graph a piecewise function. So you have to check your limit. The limit is very important. You have to be in the limit and then use the limit that they gave you. So if it's straight line, you take that 1 point already given to you, and then you do the other point. You find the other point so that you can be accurate. Thank you for watching the first part, and then the next part will be what we call unit step function. Thank you.